Hello and happy Easter. In this short video we're going to look at the various ways we can validate view models which are passed to controller methods in a .NET Core application. We're only going to be looking at server-side validation. Client-side validation, such as from a front end using JavaScript, is a different topic and we could cover that in another video. To help get things started, I've created a simple project and added one controller with one method. So our controller is for creating new bank accounts, and it has a single method which takes a post request, and if the bank account was successfully created, we just return account was created. Our methods pass a view model or an API model containing the properties of our new bank account. So as we can see, we've got a few properties such as account name, overdraft limit and currency, and account number and so on for this example. To help with these demos and for general debugging, I've installed Swagger by adding a NuGet package and configuring it in the startup program. We see the site running. You can see Swagger's found our example method, and we can try that out. And we can see it successfully called the method and returned account was created. However, there's a few problems in that we're passing in this view model here with these various properties, but we're not performing any validation at all. For example, string probably isn't a valid value for currency, and account number probably can't be string either. And we can also remove mandatory fields, and it will still quite happily create the account. So the easiest way to add validation is by adding some attributes to our view model. So we'll see that first of all. So if we turn to our view model and start at the top, so account name we're saying is going to be mandatory and has to be between 3 and 100 characters. For mandatory fields, you add the required attribute. And the best way for lengths of strings is to use the string length method. Normally you'll only be interested in the maximum length, but this attribute also supports setting a property to specify the minimum length. So now we're saying account name is required and should be between 3 and 100 characters. So for numeric values such as decimal, instead of using string length, you can use the range attribute. So the range allows you to specify an upper and lower bound. So in this case we want our number to be between 0 and 10,000. Currency is a bit harder. Again, we want it to be required and 3 letters. So we could set the string length to be like so. So it's a minimum length of 3 characters, maximum length of 3 characters. It has to be 3 characters. However, that doesn't stop somebody putting a currency being as 1, 2, 3, which isn't valid. So instead, we can use a regular expression. So the regular expression just takes a pattern as its attribute. So in this case, we want it to be between A and Z, and we want 3 characters, and then we don't need to use our string level. So let's see these attributes in action. Let's wait for the server to start up, which always takes a couple of seconds. Okay. So if we try it now, without R. That's better. So you can see the currency doesn't meet our regular expression because it just contains a string. If we remove the account name, we also get an error message for that. So the things to note here is we get a 400 bad request returned. The error messages are wrapped in this JSON document with a title, 1 or more validation errors occurred. And then also we can report multiple errors at once. So reporting there's a problem with the currency field and reporting there's a problem with the account name. If we change the overdraft limit to a negative value, that will be included as well. So it's quite nice that we can report multiple validation issues in one go back to the front end. So all 3 fields could be highlighted in the front end as containing issues. The other thing to note is all this validation takes place before even the controller is called. So if we put our breakpoint in our controller and call execute again, you see our controller is never hit. So I'm just going to change this so it doesn't keep opening a browser each time I run it, and we can reuse the same one. So using the built-in attributes is the preferred way of doing things because they're quick and easy to read and write. You can also programmatically examine your view model if you wanted to auto-generate some code for your front end. Finally, we've seen that it allows you to return multiple errors at once, which is also nice. However, sometimes these built-in attributes aren't enough and you need to create your own custom attributes, and we're going to look at that next. The first problem, before we do that, is we may notice that the error message for the currency field isn't particularly user-friendly. It says the currency must match the regular expression. A lot of users aren't going to know what a regular expression means, and so that's not particularly useful. Fortunately, we can add an extra property to our attribute to contain our own error message. So currency must be a free. In addition to just hard coding the error message against a property, you can also use a resource file if you want to localize the error messages, but we're not going to worry about that today. However, you may find that you can be using this currency attribute or currency property in more than one view model, in which case you don't want to keep recreating this logic. So it'd be nice to be able to abstract this away into its own class. So we can do that by creating our own attribute called currency code. So we'll just create a new currency code in a different class. Right. So by default, it's going to create it inheriting from attribute, but we want to use regular expressions. So, regular expressions. And that'll ask you to populate the constructor method. So we need to pass our pattern as before into the expression. So it's going to be 3 letters. So that's saying we're still using the same regular expression attribute as before, but we're automatically populating the pattern. The other thing is, as we just looked at, we need the ability to change our error message, and we can do that by overriding the format error message method. So we want that to return our error message. Again, you can be localized by injecting a string localizer and so on, but we won't worry about that now. The parameter that's passed in is the name of the property. So this is useful if your view model has multiple properties all annotated with the same currency attribute. You need to be able to tell which one the error message applies to. In this case, we've only got one, but we can include it in the error message anyway. That's working. So yes, so as you can see, it's using our new attribute and it's picked up our new custom error message. Next thing we look at is the bank account number. So the rule in this application is that a bank account number has to be 10 digits long, but the final digit is a checksum, which we compute by repeatedly summing the first 9 digits until we get down to a number between 0 and 9. There isn't a built-in attribute for doing this, so we're going to have to create our own. So as before, we'll create one called bank account number. And this time, instead of it being inherited from a regular expression attribute or attribute, we want a validation attribute. And we need to override is valid method. So the value supplied for the attribute is passed in the value property. This validation context allows you to get access to the other values in the property, but we won't need those for this example. So the first thing we need to do is we take our value in and we're going to need to cast that as a string. And then we're going to check that we've actually provided the value and that the value is 10 digits long. thing is, at this point, although we've got 10 digits, we don't know whether we've got 1, 2, 3 or A, B, C, or so we need to ensure that we've been given 10 numeric values. There's different ways of doing this, but the easiest way for this example is to use a regular expression. So our regular expression just checks that we've got 10 numbers or 10 digits between 0 and 9. And now we need to compute the checksum. So the checksum that the user's given us is the final character of the bank account number. And then we need to compute what the checksum should be by looking at the first 9 characters. So that gives us our first 9 characters. So what we're going to do is keep summing these until we get down to a single digit. So for our example, we should just do that. This isn't a particularly good way of generating checksums because although it will detect if somebody's miskeyed a value, it won't detect if somebody's accidentally transposed 2 values around because they'll still sum to the same number. But it's good enough for our example. Finally, we check that the checksum we've been given is the same as the one we've just calculated. And if all of that is true, we can then return success. So let's try this out. Waiting for the server to start, which it has. So you can see now we're getting the error message, bank account numbers must be 10 digits. So we can change it 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And now we have the bank account number, it has an invalid checksum, because if we sum the first 9 digits, we should get the number 9, not 0. So let's put a valid one in. And we can see that's now happy. So the advantage of these custom attributes is you can reuse them. So you can use them multiple times in the same view model, or you could use them in different view models, and you can also use them in different methods directly within a controller, which we might look at later on. However, sometimes you might want some custom logic that only applies to a single view model, in which case it might make more sense to put that logic directly in the view model so it's all in one place. We shall have a look at that next. So back to our view model. So we've got 2 more rules to look at. Date available, we're saying the account can't become active more than 30 days in the future, and the opening balance has to be, well, I think we're saying the opening balance has to be positive, or cannot be negative. So the way we do this is we change our view model so it inherits some validatable object. And this has a single method which we need to implement, which returns an enumerable of any validation issues. So the first thing we're going to look at is our opening balance, and we can ensure that our opening balance is not negative. And then if it is negative, we return a new validation result with the error message and the field which has got the problem. We can also check that the date available is not more than 30 days in the future using a similar method. And we shall try both of those. So we're going to say it can't be more than 30 days in the future, so we set that to next year. And the opening balance can't be negative, so we set that to a negative value. And we run these, and you may have been expecting to see those errors, but we don't. We're still seeing the original errors. That's because the validation in the view model only happens if all the attributes have successfully passed their validation. So let's fix these code up first. So we have to have the valid account name, valid currency, and a valid overdraft limit. Oops. And you have to get your JSON in the correct format, of course. Oops, again there. Right, okay, so because these attributes are now valid, it now does the validation of the view model, and you can see we've got accounts must be more than 30, cannot be opened more than 30 days in advance, and accounts can't be opened with a negative balance. And we can fix both of these up. And now it's passed, and you can see it's actually hit our breakpoint. So we've looked at doing validation with attributes, and we've also looked at doing validation directly in a view model. Sometimes, however, we might need to do something a bit more complicated than that. For our final example, we're going to look at the customer ID. So the customer has to exist in the database. We could do this validation within the view model. However, quite often in the controller, not only do you want to check that a customer exists, but you also need to use some of their properties, such as maybe the first name or date of birth. And so for performance, you probably don't want to retrieve it twice. So you'd be better off obtaining that information directly once in the controller. So for our example, we're going to say we've only got one customer in our database, and that has an ID of 100. So we can say if customer ID equals or does not equal 100, then we've got a problem. And the way we report a problem back is we use model state add model error. The key is the name of the field that's causing the problem. So in this case, it's going to be the customer ID, but rather than hard coding a string, we can use the name of method. And then we can add our error message. So customer not found. Then we need to return the error message back from the controller. So we want to report a bad request, so we do return bad request, and we pass in the model state as the details to return. However, a slightly better pattern is if you're going to perform multiple bits of validation. So for example, we might also want to say account name is not David. So we've got two rules now. We're saying the customer ID cannot be 100 and the account name cannot be David. However, as we're written at the moment, only one of these attributes will be checked at a time. If the customer ID is not 100, then it's going to return at this point and it won't tell you the second error message. A better pattern, instead of returning from within the if statement, is to add an additional check after you've done all your validation. And say if the model state is not valid, then we can return it. This way, we end up reporting both errors, not just the first one we find. So now we're getting the error, customer ID not found. And what we've done right is not finding everyone. Oh, if it's not equal, yeah, should be equals David, shouldn't it? Never mind. And we've got our second error as well. However, you may notice that the format of the error has changed. We're still getting a 400 bad request returned, and we're still getting our multiple error messages, but we're not getting the JSON payload around it. So we're not returning the errors in a consistent way. Because we want to really return errors in the same way, regardless of how the validation is carried out, because it makes it easier from the front end, we need to change our code. I should fix this bug first of all. And the way we do that is instead of returning bad request, we return validation problem. And now you can see we have the same payload as before, the title and so on. And we can add our second error message back in. So, I mentioned earlier that the nice thing about using custom attributes is you can reuse them in other places, and one of the places you can reuse them is directly within methods within your controller. So we can write a second method in our controller for retrieving the details of accounts. So this time it will be an HTTP GET method. And the thing we're going to pass in is the account number. Details of account. Right. And our account number is going to come from our query string, so we can specify an attribute that says it's a query string. But the other thing is we can also provide that same validation, because as before the account number's got to be 10 digits and have a valid checksum. So you can also specify the attribute to use that. So we return back to Swagger, and this time we'll have to refresh it so it picks up the new method. So we've got our GET request now, and if we give it an account number, you can see it's carried out the same validation as before. It has to be 10 digits. And I can never count. And if you put a valid one in, then it all works. So we've looked at a few different ways we can validate view models. We looked at account using attribute validation, which is the preferred solution because it's simple to write and read, and it keeps all your code in one place along with the view model. We looked at custom attributes, which are good if you want to reuse your validation in multiple places, such as different view models or maybe directly in controllers. We looked at view model logic, where we embed the validation within the view model. So that's useful when it's only going to be used once and you want to keep all the logic in one place. And finally, we looked at actually doing validation in controllers where you've got more complicated requirements. Thank you for watching.